Hello, this video will be a short one. I just wanted to show you a particular datasheet for cathode ray tube being used in oscilloscopes. This was back in, I think, 1970s. It's interesting in many ways because it shows what kind of technology was available back then. Well, I have to make some mentions. First of all, this was released in Germany. It was released in Eastern Germany. As you can see, it's written in Deutsch. And the way in which the tube is being identified shows clearly the Russian system. And I thought this is being one of the interesting aspects because you have to understand that there was a large difference between what you would have available in Eastern and Western Germany. And the way in which products were released meant that you would have to consider a lot of details when you would make a purchase. Of course, this kind of tube that could be used in an oscilloscope was quite expensive. Why would you buy such a thing instead of a full oscilloscope? Because of price. You have to think that such tubes cost around the equivalent in today's money of around, I don't know, a couple hundreds of dollars, which is quite a lot, but a full oscilloscope would cost in the thousands of dollars. And if you would not have the means of buying such products on the wholesale market, and think about this as being totally unavailable back then, and thinking that the market was not able to offer so many products because, of course, wages were not at the level you may see today, meant that some hobbies made an attempt at building their own oscilloscope. Of course, it would have various limitations because of the fact that you would have to buy so many other components, find them, and build your own circuit. However, this was a path some passionate hobbyists took, and some of them had a lot of success. So first of all, let's mention some of the obvious aspects. 8, I don't know exactly, it's a Russian character. Again, a Russian character. I don't know the actual notation, and I don't want to use the internet in order to make some sort of shortcut in this case, but I would like to mention what I think is the most important aspect. I mentioned in a previous video about the Phillips notation. In this case, we are looking at the Russian notation, and the Russian notation is very similar to the American one as far as we are concerned with a couple of aspects. First of all, the first number over here is the filament voltage. This was very important because you would have to drive the picture tube at precisely that voltage. If you would drive it at lower voltage, it would have an acceptable performance, and it could be living even longer, but it would have less brightness and probably less contrast. So this was something you would have to consider. If you were driving it past that voltage, you would seriously shorten the lifetime of it. So this was the most important aspect you would consider. Next, the weight of it, 450 grams. This is not much, not little. I don't know exactly how much this was important. Then you will see the socket, and of course every picture tube may have had a different socket. There were tens of sockets, yes, that may have been released for various CRTs. So for instance, for a TV set, for an oscilloscope, and so on. Another very important aspect is the difference between using a magnetic deflection CRT and an electrostatic one. The electrostatic one is very interesting because it uses a particular voltage in order to deflect the beam, and this voltage has to be supplied to these plates. This is, I think, the focusing ring. Some plates, one of them probably controls contrast. I don't know exactly. I don't remember those details. I didn't have a formal education in this area, but I was interested in how some ways operated. So you have to understand that my knowledge is at the hobbyist level, and even so it's less than you would imagine. So the electron beam was being sent from the cathode and then deflected on the screen as needed in order to show the signal that was being provided. And of course, there were some various specifications you would have to consider. For instance, in this case, you see the voltage. I think that this one is the In this case, I think I made a mistake. It's not the American. It's not the American system. Probably it's the size of the picture tube, and I think that it's quite clearly that. Why? Because when I'm looking over here, I see a 6.3 volt being mentioned, and 6.3 volts probably pertains to the filament. So this one clearly is wrong. You have to understand very well the way in which those devices were being presented. Then, and of course, a 6.3 voltage was a very common heater voltage. Then you would see some other specifications that I note. Signal platen, probably it's the signal grid that could probably be controlled by the signal, and it says that it could be 0.19 millivolt per volt. I think that is sensitivity. I don't know German. Okay, current. This is probably the heating filament current. Anode voltage 516 volts. So probably you're talking about one of the acceleration. One of the acceleration grids. 1.5 kilovolts. This should be the final one. Anode 2. Yes, I think those are. It's interesting to note because in this case you don't have a connection to the actual front part of the screen, like in a classic TV set. You would have to use those deflection voltages and acceleration potentials in order to send the beam to the screen. Of course, it's less, it's precise, but it doesn't have the same potential as using the classical system that was being employed on the TVs. However, it's very precise. One of the reasons why such a system is being used is also due to the fact that you could make measurements using an oscilloscope. And back then you would have a reticule on the screen, and then if you would look on each and every let's say location, you would know that the distance between two squares would be a particular voltage, and everything would be set through switches, and then every division would be 1 volt or so, and you could guess how what kind of peak voltage and you would get on a signal just by looking at the screen. So having those values, it was extremely important. And what we are seeing over here, 6.9 volts. This is the maximum voltage for the filament. 6.9 volts maximum, 5.7 volts minimum. I assume that this is in order to make a reliable picture with the same characteristics. In general, if you would underdrive the filament, you would have better longevity, but however, you would have to trade off some of the contrast and brightness capability on the screen. 1.1, 2.2 volts maximum acceleration voltage, 1.5 minimum. Of course, with a higher acceleration voltage, you would see a brighter picture, but you would wear off quicker the emission material. All right. The voltage on the cathode, 125 volts maximum, minimum 0. I think that if you would use the cathode voltage you would send 0 volts to the cathode, all the emission from the filament would get on the screen, and then you would have a very high brightness point. Or if it's being deflected by the signal, it would show your signal. And a very high voltage would mean a very low brightness. In general, as in other cases, trying to drive less of a current on the screen would mean that your CRT would be less affected by wear. But of course, it depended on your application what was acceptable. So 125 volts, this would mean a very dim dot, and 0 volts, which would mean a very high intensity one, probably one that could damage the emissive surface. Performance being certain between 5 and 35 degrees Celsius. Okay, so this is how you would probably use such a data. You would try to see if it's appropriate to your application, or if you were trying to find an equivalent for another CRT, and this was possible even for TV ones, not for oscilloscopes ones. You would have to look on these data sheets, on these catalogs, and this was how it was done. So I hope it was interesting, even if probably it wasn't such a spectacular way in which I presented, but those are the limitations. I'm not more knowledgeable in this respect. Hopefully it was interesting. Have a very nice day.